Hello everyone, this is Mr. McMillan, and I'm here today to talk about the answer key video for the practice problems for the notes that we did on Monday on determining similarities, scale factors, and similarity statements. Okay, so we're going to go through each of these problems. Some of these were already covered in the instructional video, but I'm going to go ahead and rehash them here while we have the opportunity. So on the first 6 problems, it wants us to determine whether the pairs of figures below are similar. If so, we want to state the scale factor. So what we want to do here is we want to look at our ratios of sides and to see if they are proportional, and if we want, and we need to see if our angles are congruent. Okay, so we need both of those conditions, congruent angles and proportional sides for all the sides in order for these two figures to be similar. Okay, so let's look at the first one. The first one here, we have two shapes, and the first thing we're going to do is check the angles, because if the angles are not congruent, then they're not similar by default. And in this case, we have an angle that's 105, and by the properties for these shapes, which we'll talk about more next semester, these angles would all be congruent. Okay, so we have 105 degrees and everything else, it would be congruent. So now let's look at the sides. We have a side length of 10, 10, 12, and 12, and then we have 25, 25, 30, and 30. So what we need to do is use the appropriate corresponding sides. So we have 10 over 25, and since that happens twice, we only have to do it the one time. 10 over 25 simplifies to 2 over 5. And now we need to see if the same is true for the other ratio. So we have 12 over 30. 12 over 30 simplifies to 2/5 as well. These are the same. So that means that these are similar. And the scale factor would be 2 over 5 or 5 over 2, depending on whether you did the small over the large or the large over the small. Let's look at number 2. We're going to look at our angles first. We see that we have 4 right angles in both of these, so that means we have 4, every angle is congruent. So now we need to check the ratios of the sides. So we have 4 over 8, and 4 over 8 reduces to 1/2. And then we have 6 over 16. 6 over 16, we can divide both of these by 2, and that gives us the fraction of 3/8. 1/2 does not equal 3/8, so the sides are not proportional, so that means that these are not similar. Next up is number 3. Number 3, we have a 120-degree angle here for this obtuse angle, and we have a 60-degree angle here. These are supposed to be supplementary, which means this would be 60, so these would be congruent. So we have the angles that are congruent, so now we need to check the ratios of our sides. So we have 7 over 21. 7 over 21 gives us 1/3, and then we have 8 over 24, which is 1/3 as well. So these check out. So these are similar, and the scale factor is equal to 1/3 or 3, depending on the way you did it. If you did it the opposite way, you'd have 21 over 7, which is 3, or 24 over 8, which is 3 as well. Number 4, we're looking at our angles first. And we immediately see this angle here is 130, while this angle here is 120. The angles are not congruent. So that automatically rules out these being similar figures. So these are not similar. Number 5, if we check our angles, our corresponding angles are indeed congruent. We can tell because of the congruency markings. This is a trapezoid, and we have 3 different ratios to test this time instead of just 2. So we take 3/6, which is 1/2. We take 6/12, which is 1/2. And we take 8/16, which is also 1/2. All 3 of these give us 1/2, and that means that these would be similar. And our scale factor would equal 1/2 or 2, depending on how you did it. And then finally, number 6, for these problems, you have the angles are 65 degrees and 115 degrees. And if you subtract 65 from 180, you'll end up getting 115 here as well. So the angles are congruent. Now let's look at our side ratios. So we have 5/16. This does not simplify. And then we have 5/20, which simplifies to 1/4. These are not equal. The ratios are not the same, so these would not be similar. Okay. All right, next up, the next few problems. We want to find the missing length that's indicated by a question mark. The triangles in each given pair are similar. Okay, so what we're going to do is we're going to identify which ones are what we're looking for. So we have our question mark here on DE for 7. And what I like to do is I like to start out with that side because it's our unknown. So DE is our unknown. And since we're dealing with similar figures, we need to set up a ratio. So DE over something. Well, DE is in the first and second spots. In the other triangle, UV is in the first and second spots. So we can say that DE has to go over UV. Well, to set up a proportion, we need 2 ratios. Now, we use this side already. We have to go back to this triangle. So CD is the only other side that's labeled. CD is in the second and third spots. VW is in the second and third spots as well. So that means that CD must go over VW. Now we plug in our values. DE is X. UV is 16. CD is 65. And VW is 20. Now we have our proportion set up. Now we need to cross multiply. So we cross multiply here. So we get X times 20 is 20X equals, and then 16 times 65. I need to get my calculator, I apologize. $16 times 65 gives us 1,040. Then we need to get rid of the 20, so we divide both sides by 20, and we get that X equals 52. Number 8. Number 8, we have BC as our unknown, so we're going to start our ratio out with that. BC is in the first and second spots. In the other triangle, BG is in the first and second spots. Now we need another ratio to set equal to it. Then we have BD from this triangle is the only other one that is labeled because we have to go back to our original triangle. BD is in the first and third spots, and BH is in the first and third spots on the other end. So BC over BG, BC is X, BG is 14, and that's equal to BD, which is 33, over BH, which is 22. Then we cross multiply. 22 times X just gives us 22X. 14 times 33 gives us 462. Divide both sides by 22, and you find that X equals 21. All right, number 9. Number 9 looks a little bit different, so we need to make sure that we pay attention to what we have. Now this time, instead of being two separate triangles that are distinctly separate from one another, we have two separate triangles that are overlapping one another. And we can see we have a smaller triangle here with QLK and our larger triangle QSR. So what we need to do, we're trying to find QR. So we're going to start out with QR as our side. QR is the larger triangle, and the corresponding side to QR is on the same side of with the smaller, which is QK. So QR must go over QK equals. Now we have a choice. We can either use this set of sides here, or we can use these two sides. It doesn't matter which one you choose, okay? I'm going to choose the bottom sides, but you could choose the left sides just the same. So we started out with the big triangle, so we need to go back to the big triangle. So we have SR over, and then the corresponding side is LK. So now we set up our proportion. QR is X, QK is 8, SR is 63, and LK is 9. Cross multiplying to solve our problem, and we get 9x equals 336. No, I'm sorry. Nope, I apologize. 63 times 8 gives us 504. Sorry about that. Divide both sides by 9, and you get that x is equal to 56. Number 10. Number 10, we're looking for DE. So we're going to start our proportion off with DE. DE is in the first and second spots. KL is in the first and second spots, so we're going to put those over one another. Equal, now we have to go back to this triangle, so we're going to use DF over KM. So substituting our values in, we have x over 16 equals 121 over 22. We cross multiply. We get 22x is equal to 1936. Divide both sides by 22. And you get that x is equal to 88. Number 11. Number 11, you have triangle MLK is similar to triangle MFG, and we're trying to find GM. So we're going to start out with GM. GM is in the first and third spots, and the first and third spots from the other triangle is MK. So we're going to use MK with GM. Then we need to go back to this triangle, so we're going to use FM next. FM is in the first and second spot, so we're going to use ML. Then we substitute in our values. GM is X, MK is 30, FM is 10, and ML is 60. Cross multiplying, we find 60 times X, which is 60X. 10 times 30, which is 300. Divide both sides by 60, and you get that x is equal to 5. Next up, number 12. Number 12, we see a question mark in these overlapping triangles here, and we see that AL is what we're trying to find, and it is from the small triangle. AL, the corresponding side to AL, is AB from the larger triangle. Then we have our choice of sides for the other ones. I'm going to use the bottom sides, and we need to start with the small triangle again since we started with it to start with. So we have AM over, and then we have AC. AL is X, AB is 130, AM is 54, and AC is 117. Now we're going to cross multiply, and we get 117. X is equal to 7,020. Divide both sides by 117, and we get X equals 60. Number 13, we're looking to find TS. So we're going to start out with TS. TS is in the first and second spots. DE is in the first and second spots. Then we have to go back to the original triangle. So we're using TU over. And we have the second and third spots, and EF is our second, third spots. TS is X over DE, which is 14, equals TU is 39, EF is 26. Cross multiply, we have 26 times X equals 39 times 14. 39 times 14 is 546. Divide both sides by 26, and you get that X is equal to 21. And number 14, we're looking for BS. So we're going to put an X on it. BS is in the first and third spots, which is the same place that BD is. So BS over BD is equal to, then we go back to our original triangle, so we use BR over, then we have BC, BS is X, BD is 130, yes, equals, then we have BR, which is 50, over BC, which is 130, cross multiply, and you get 130X equals 6,500. Divide both sides by 130, and you find that X is equal to 50. All right. Number 15. Number 15 and through 22 want us to solve for X. The triangles in each given pair are similar. So we're doing the exact same thing. We have to set up ratios and then solve. So first off, we're trying to find ET. We're trying to find X, which is on ET. So we're going to start out with ET. ET corresponds to ST. Then we need to go back to our small triangle here, which is DT over RT, our large side. ET is 3x minus 1. ST is 22. DT is 11. And RT is 22. Now we're still going to cross multiply to solve these proportions. Now I'm going to write it out as 22 times 3x minus 1 equals, and then we have 11 times 22. 11 times 22 is 242. Now, whenever you have a number outside a set of parentheses, what you need to do is distribute it out. So you're going to multiply 22 by both the 3x and the negative 1. 22 times 3x is 66x. 22 times negative 1 is negative 22, and that's equal to 242. Add 22 to both sides, and you get 66x is equal to 264. Divide both sides by 66, and you get x equals 4. Number 16. Number 16, our x is on side EF. EF is in the second and third spots. In the other triangle, RQ is in the second and third spots. So we are using QR. And that's equal to, we have to go back to the original triangle, which is ED, over, and then SR. EF is X minus 6. QR is 56. ED is 14. And SR is 112. Cross multiplying, we have 112 times X minus 6 equals 14 times 56, which is 784. We're going to distribute out the 112, and we get 112X minus 672 is equal to 784. Add 672 to both sides, and you get 112X equals 1456. Divide both sides by 112, and you get that X equals 13. Number 17, we have triangle, we have an X in our UH, so we're going to start out with UH. UH is in the first and third spots. In our other triangle, the first and third spots are UW. So UH over UW equals. Then we have to go back to our original triangle, which is UG over. And then UG is in the first and second spots. UV is in the first and second spots. So UG over UV. UH is 2x minus 9 over UW, which is 33. And this is equal to UG, which is 5, over UV, which is 15. Cross multiply, and we get 15 times 2x minus 9 equals 165. Distribute the 15 out to both the 2 and the negative 9, and you get 30x minus 135 equals 165. Add 135 to both sides, and we get 30x equals 300. Divide both sides by 30, and we get that x equals 10. Number 18. Number 18, we have an X on side LM. So we're going to start out with LM. LM overlaps with side LB. Then you can choose which set of sides you want to use for the other bit. I'm going to use the left-hand set of sides, but you could use the bottom and get the same answer. It'll just look a little bit different while you're solving it. So we go back to the large triangle, which is LN, over, and then we have LC. LM is 55x plus 3 over LB, which is 36, equals LN, 126 over 27. Cross multiply, and you get 55x plus 3 with 27 out front equals 4,536. Distribute out the 27. 27 times 55 gives you 1485x. 27 times positive 3 gives you positive 81. Subtract 81 from both sides, and you get 1485x is equal to 4455. Divide both sides by 1485, and you get that x equals 3. Number 19, you have an x on RS. So that's what we're going to be using first. So we have RS. RS is in the first and second spots. NM is on the first and second spots for the other one. RS over NM. RS is 2x minus 8, or excuse me, we still have to set up a ratio. Then we go back to our original triangle. So we use RT over, and then RT is in the first and third spots, which is where NL is. So we're going to use that one. RS is 2x minus 8 over 42 equals 8 over 24. Cross multiply, and we get that 24 times 2x minus 8 is equal to 336. Next up, we distribute the 24 to both 2 and negative 8, and so we get 48x minus 192 equals 336. Add 192 to both sides, and we get that 48x is equal to 528. Divide both sides by 48, and you get x equals 11. Number 20, we have an x on UV. UV is in the first and second spots. UB is in the first and second spots. Then we go back to our original triangle, which is UW. UW over UC. Setting up our equation, we have UV, 6x plus 15, over 27 equals 88 over 24. Cross multiply, and we get that 24 times 6x plus 15 is equal to 2376. Distribute out the 24 to the 6 and the 15, and you get that 144x plus 360 equals 2376. Subtract 360 from both sides, and you get that 144x is equal to 2016. Divide both sides by 144, and you get that x equals 14. Number 21, we have an x on UP. UP are in the first and second spots. PQ are in the first and second spots on the other one. Then we go back to TP, and TP corresponds to RP. UP is 2x minus 18. PQ is 24. TP is 13, and PR is 39. Cross multiplying, we get that 39 times 2x minus 18 equals 312. We need to distribute out the 39 to both the 2 and the 18. So we get 78x minus 702 equals 312. Add 702 to both sides, and you get 78x equals 1014. Divide both sides by 78, and you get that x equals 13. And finally, number 22. Number 22, we have an x on CB, so we're going to start out with that. CB corresponds to EF. And then we go back to CA, which corresponds to EG. CB is 2x plus 9. EF is 21. CA is 60 over EG, which is 36. Cross multiply, and you have 36 times 2x plus 9 equals 1260. Distribute the 36 to both the 2 and the 9, and you get that 72x plus 324 equals 1260. Subtract 324 from both sides, and you get 72x equals 936. Divide both sides by 72, and you get x equals 13. So that's it for this video, guys. You weren't required necessarily to do all these, but I do hope that you watched if you're having some difficulties with it, or at least checked your answers and read through the answer key. If you do have questions about this, please let me know. There's also an iExcel on this that I'll be sending out in an email, or I've already sent out in an email that deals with finding missing sides that will give you instant feedback. Thanks, guys, and I will see you in the next video.